Welcome to video 17 of the Discrete Math video series, and in this video we're going to solve the exercises introduced in the previous one. So to begin with, we're going to demonstrate that the following two propositions are not equivalent to each other by building their truth tables, or rather building the truth table of the biconditional between them. And so just to save you from having to watch me draw out a lot of the truth table, I've already kind of pre-generated some of it. And you can see here that I am quickly filling in the remaining truth values, computing it, from the low level up to the high level, so to speak. And so once we get to the biconditional symbol, we'll have the actual truth table for this thing. And because you can see that it is all true, then therefore that means that the two sentences are equivalent to each other. Now we'll go ahead and grab the other two propositions that were described in the exercise and form the biconditional. And yet again, I'm quickly computing the truth table for that. And by the time we get to the biconditional, then you can already see that not all of the values are true, and therefore these two propositions are not equivalent to each other. So here we're going to give a quick argument that every two tautologies are equivalent to each other, every two contradictions are equivalent to each other. And so what you see here is just kind of a quick demonstration of what's going to happen at every row of two tautologies. You're always going to have true left right arrow true, and that is always going to evaluate to true, because recall the rule for the biconditional is that it comes out true if the two sides share the same truth value. So that's why two tautologies are always equivalent to each other, is that when you form the biconditional, it's always going to come out true. So the biconditional is a tautology, and so the equivalence holds. Well, in fact, we're also seeing that basically the same thing happens for the contradiction, because with a contradiction, both of them are always going to come out false. But again, recall the rule for evaluating a biconditional is that it is true when the two sides have the same truth value. Well, false and false is the same truth value. Therefore, the biconditional comes out true at every single row for these two contradictions. And so since the biconditional comes out always true, it's a tautology. That means that the two contradictions are equivalent to each other. Now to demonstrate that not every two contingencies are equivalent to each other, then let's just write down, like a sentence P, a sentence Q, and regard it as, completely different propositions, unrelated propositions maybe. Then when we form the biconditional between the two, right? I mean, like P is a contingency, Q is a contingency. When we form the biconditional, we write down its truth table, and we see that at some rows it is true, and at some rows it is false, and that means that these two are not equivalent to each other.